So the next problem we will discuss from the Hastags SDE sheet is the problem number 4 from day 5. So what's the problem states? We are given the head of a linked list. Remove the kth node from the end of the list and return its head. So what we are given? We are given the head of a linked list and we have to remove the kth node from the end of the list and return its head. So basically we have to remove the nth node from end of the list. Let's suppose this is the given linked list. So the second node from the end we want to remove. So this is the linked list 1 2 3 4 5. The second node we want to remove from the linked list is from the end 1 2. So the second node from the end is removed, so the output is 1 2 3 4. So now we will explain the question. तो हमें लिंक लिस्ट दे रखी है. So we are given the link list and we have to delete the nth row from the nth node from the end. So we have to delete the second node, that is 1 and 2, this node from the linked list. So the resultant linked list is this one. Okay, so how would we solve this question? So what we can observe is that the nth node from the end which we want to delete is basically the, if we assume that the length of the linked list is L. So what we can say is that the nth node from the end is basically L minus 1 plus 1th node from the front. So the nth node, that is the second node from the end. Let us take the example. The nth, this is our linked list 1 2 3 4 and 5. This is our linked list. The second node from the end is this one, okay, which we want to delete. And what I am saying, from the observation we can conclude that the nth node from the end is L minus n plus 1th node, that where L is the length of the linked list. So for the given case the length of the linked list is 5, nth node is 2, so 5 minus 2 plus 1th node from the front, so that is 4th node from the front. So 1 2 3 4. So this node, so these two are the same node. So what we can conclude, our question is now we have to remove the L minus n plus 1th node from the front, L minus 1th row from the front. So how will we solve this question? We can linearly iterate over the linked list. To find the length of the linked list. Okay, we can linearly iterate over the linked list to find the length of the linked list. Okay, and the nth value, the n value is given to us, so we can find the L minus 1th node because we have found a value from this. Let's suppose the length is 5 minus 2 plus 1 is 4th node from the beginning, so we linearly iterate over the linked list. And find the 4th node and we also maintain a temporary pointer that will point to this node, because we have to make a new link from this node to this node and delete this one node. So this approach requires a time complexity of order of n to find the length of the linked list, okay, and order of n more time complexity, and order of n more time complexity to find the L minus n plus 1th node, okay, in the worst case. So the time complexity in the worst case is order of n, and what is the space complexity to solve this question? The space complexity to solve this question is, because we are not using any auxiliary space, so we are the space complexity to solve this question is order of 1. So this is the nice solution to solve this problem. So how can we use an optimal approach to solve this question? So what we'll do, so what is the optimal solution to solve this problem? So what we can do, let me draw a linked list: 1, 2, 3, 4 and 5. So what we can do is use two pointers, first pointing to the start, let's suppose it's t1, and one pointing, let's for this case n value is 2, and one pointing to the nth node from the front. So nth node from the front is this one, so this is t2, and we linearly iterate over the linked list and increment the pointer by one node, so until t2 reaches the end. So at the next condition, a t2 will point to this, t1 will point to this. We linearly iterate over the array, t2 will point to this, t1 will point to this, t2 will point to this, and t1 will point to this. And when the t2 pointer has reached the end of the linked list, the node that at which the t1 points is a node we want to delete. So it is basically the second node. It is basically a second node from the end which we want to delete. So this is the basic approach we will follow. Now we look at one more test case. We'll take one more example. So we have a linked list of size, let's suppose 7 size linked list, and we want to delete the 7th element from the end. So basically what we want to delete: the first, the second, the third, the fourth, the fifth, the sixth, the seventh. So we want to delete this element. So what approach I would follow to delete the 7th element from the end? Uh, so the same approach which we have discussed earlier. One pointer will point to this, that is t1 points to this, and t2 points to the nth node from the starting. So nth node from the starting is, so 1th, 2nd, 3rd, 4th, 5th, 6th, 7th. So 7th node from the starting is this one, and we have to check the condition. If the second pointer is pointing to the next to the end, or to the end node of the linked list, then we have then t1 is the node we want to remove. So t2 is pointing to the end of the linked list, so t1 is the node we want to remove, so we can easily remove t1. So this is the approach we will follow To solve the question, delete the nth node from the end. Now we'll discuss the code. Now we look at the code. So we have a first pointer pointing to the head node. The second pointer, initially it is pointing to null. If we are checking for the base condition, if head equals to null, we have to maintain this condition at the starting. If head equals to null, we'll return null pointer. Otherwise, we'll make two pointers, first pointing to head, the second pointing to null pointer, and we are making the second pointer. This condition will is making the second pointer points to the nth node from the beginning. So this code makes the second pointer points to the nth node from the beginning. And what we have to do, we have to linearly traverse the linked list until the second pointer points to the last element of the linked list. And we are simultaneously making the first pointer point to the next node. So I have explained it in the comments, and when the second reach the last element, the first will point to the nth node from the end. Okay, so our second pointer is pointing to the nth node from the beginning, and we are incrementing at each step. We are implementing the first and the second node such that when the second node reaches the end node, we are taking care the first node is pointing to the nth node from the end. So this is the condition we are taking care of. So this condition take care of the previous node that we want to remove. If the previous node is null, then that node must be that node which we want to remove is the first node. Then what we have to do, we make the head pointer points to the next value, because we want to delete the first node from the linked list. And if it is not the if the node which we want to remove is not the first node from the linked list, what we want to do, we want to remove the first. Before that, we want to update the node that is previous to the deleted node, the node which we want to delete, and the temp points to the node that is previous to the node which we want to delete. So we want to update the address pointed by the node previous to the node which we want to delete to the node that that is next to the node which we want in our linked list. And we delete the node that is the nth node from the end, and we return the head of the linked list. So this is the so we have run the code. It has run successfully. Now we'll try to submit it. Our code is accepted. So this is how we solve the problem, remove the nth node from the end of the linked list.